Hi, I'm Rich with insideHPC. We're here at SC17 in Denver, Colorado, and today we're at the Kingston booth with Rich. So Rich, let's start at the beginning.
Okay.
Who is Kingston, and who do you help in this HPC space?
Okay. Kingston is a 30-year-old company. We're celebrating our 30th year in the PC industry. So we've been around a long time. We started in the DRAM space, and then we expanded in the flash card, flash USB drive business, and now we're in the SSD space. So we actually provide the DRAM that fuels basically most of the systems you see on this floor, as well as very high-power SSDs that help in very HPC applications, very storage-intense applications.
Oh, perfect. Well, Rich, what are you showcasing here at SC17?
That's a good question, Rich.
Yeah,
So let's step over here.
Okay.
So at the top, we're showcasing some of our memory modules. These are memory modules that we've been offering for the last 30 years. We have server memory modules that power many of the servers you see here, notebook memory modules or desktop memory modules. Just to place it in perspective, most of the people here buy their memory from the commercial channel, and we're the largest vendor of memory modules and SSDs apart from semiconductor manufacturers. So our brand is very well known. And then we've got a whole bunch of SSDs here. So let me start first with SATA. SATA is the older storage technology. And we have consumer grade SSDs like the A400, the UV500, which are the leading SSDs that are shipped in the market space. And then the DC400 is our enterprise grade. This is for servers doing intensive work, intensive read-write applications. And then M.2 is in the back. That's the small card that you see that is used in a lot of notebooks today and in some of the desktop motherboards. Now we shift into NVMe. SATA technology is basically going away in the next few years. And SATA is being replaced by PCIe SSDs, often called NVMe SSDs. And these SSDs are extremely fast. So this is a U.2. It's a 2.5-inch NVMe PCIe SSD. And it'll take over the server space within the next 3 years and displace SATA. To show you the performance difference, a SATA SSD can give you about 550 megabytes per second. These drives can give you 3,600 megabytes per second. So you're talking a whole magnitude of HPC computing that you can do. We're also showcasing the DCP-1000 that is currently shipping. We have this available today. This is the world's fastest SSD today. It'll give you bandwidth of 7 gigabytes per second for one drive. It's built internally with 4 drives. It's designed by our partners Liquid, who are also at the show. And this is so fast that it really speeds up a lot of the applications that are being done in the HPC space. So this is the kind of card that will really help people here who are doing a lot of computational intensive applications. And then here we're showing the M.2 version of the NVMe SSD, and that's used in a lot of desktops and notebooks today. And they'll give you, for example, 2,700 megabytes per second read speeds. So you're seeing a lot of performance, 1,600 megabytes per second write. And then for people who don't have the slots on their motherboards, we offer a card. So they can put the M.2 NVMe SSD onto this card, plug in straight into their older desktop, and suddenly they have NVMe with all the modern operating systems. So that's a lot of performance here. And this is the way the industry is going, from SATA into NVMe for high performance.
So what else you got here?
Okay, let's walk over here. So this is our wall of video. There's another wall on the other side, and basically you can see each one is a high definition stream. We have over 480 streams being shown here on this side and the other side, and you can see all the videos are basically streaming, and they're streaming off one card, the DCP-1000 that you saw earlier. So if you look at the system here, it's an Alienware system with one of those cards streaming all these videos real time. So it shows you the power of one SSD to accelerate a workload. To do this with SATA, you would need over a dozen SSDs that you would have to put together to get this kind of performance. Now with one card, you can do this.
Well, Rich, kind of a wrap-up question I want to ask you. How is this new high-speed memory, how is it changing the way HPC people are doing their work?
Well, basically with NVMe SSDs, think of them not as a storage device, but as an accelerator. It accelerates your work. So not only does it make storage faster, it's catching up to it's reducing the latency that you have with storage normally, but at the same time, it's saving you CPU cycles. NVMe saves you about a third of your CPU cycles saved on storage. So imagine getting a processor boost just because your storage is that much faster. So we recommend to everybody here, if you're doing HPC work look at our NVMe accelerators. They will really make your life easier. And finally, one point we'd like to say, people go, this must be very expensive. It really isn't. If you compare that card with the equivalent setup with SATA SSDs, the price would be about the same. So actually, they're very affordable and available today for the DCP-1000 up to 3.2 terabytes.
Well, Rich, have a great week. This sounds exciting, and we'll see you next year at SC18, right?
Yes, 2018. Thank you, Reg.